Okay, my name is Nancy Roberts and I'm an economics professor at Arizona State University. Today we want to continue with a discussion of production, and I'm going to use this same production schedule that we've been working with, and I want to talk about the relationships between total, marginal, and average. And so let's start with the relationship between marginal and total. Now, what I've drawn here very quickly is the shape of this total product curve. And what's interesting, something that I want you to think about, if I give you column 1 and 2, you can construct this column. In other words, the difference between here and here is 10. The difference between here and here is 15. So you understand how to construct this column. But what's interesting is if I ask you for a formula for this, you get a little nervous. And so what I want to do is show you how it's easy to get from column 1 and 2 to column 3, or to get from column 1 and 3 to column 2. And to do that, I ask you to look at this total product curve. On this axis, I have output, or total product. On this axis, I have labor. My question to you is, what is the slope of this curve? And your answer is, well, change in y over change in x. That's the slope of this curve. And so if we were to write the slope of this curve, the slope is change in total product over change in labor. So that's the slope of that curve. But in fact, if you look at this, what is marginal product? It's the change in total product divided by the change in labor. Now, our labor changes by 1 every time, so in each case we're dividing by 1. But if I put these outputs up here by 2s, we hire 2 people or 4 people or 6 people, then you divide by 2. But what you will notice is that this is actually the formula for marginal product. So marginal product is in fact a representation of the slope of total product. And it doesn't matter what variable you're talking about. We're going to be talking about costs. We're going to be talking about revenues. We're going to be talking about profits. Marginal is always a representation of the slope of total. And if you will remember, and look at our marginal product curve, it's increasing, increasing, increasing. Then it starts decreasing, decreasing, decreasing. And somewhere between 7 and 8 workers, it actually becomes 0, and then it goes negative. I want you to look at the slope of this curve. At this point right here, that's the slope. At this point right here, that's the slope. At this point right here, that's the slope. So the slope is positive and increasing. As we continue up here, the slope is still positive, but now it's approaching 0. And at this point right here, the slope is 0. And then over here, the slope actually turns negative. Look at what marginal product does. It's doing exactly that same thing. And somewhere between 7 and 8 workers, marginal product is 0. Well, that's right in here. Worker number 7 is at 80. Worker number 8 is at 78. So somewhere in here, the slope goes negative. So marginal product is always a representation of the slope of total. And so there's just a picture of it, and that's how you can always think of those two in relationship to one another. Okay, we've discussed the relationship between total product and marginal product. What I want to do now is discuss the relationship between marginal product and average product. And it's not as complicated as you might think. So, every one of you knows what your grade point average is. Let's assume your grade point average is 3.0. And you come in and take an economics class. Okay, the economics class is the additional class. It's the marginal class. What is the relationship between the marginal class and the average class? That's the question we're asking. Well, if your average classes so far are 3.0, and you come in and take an economics class, and you make an A in the economics class, then this marginal class is above your average, and it's going to pull your average up. If you have a 3.0 GPA, and you come in and take an economics class, and you make a C in this economics class, then what happens is the C in the economics class is below the average of all your classes, and it's going to pull your average down. That is always the relationship between marginal and average. Marginal's in charge. Marginal's going to jerk your average around. If marginal is above your average, it'll pull your average up. If marginal is below your average, it'll pull your average down. I don't care what averages and marginals we're talking about. If we're talking about your batting average, if your batting average is 300 and you go out in tonight's game and you bat 4 for 6, 4 for 6 is above 300, it's going to pull your average up. So it doesn't matter what the variable is that we're talking about. The relationship between marginal and average is always the same. In fact, what I've done here is put marginal and average together using this same data, and you can see what happens to average. It's getting pulled up, 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 and the reason it's being pulled up is because marginal is above it. In other words, the marginal product of the second worker is 10. The average product of 2 workers is 7.5. So marginal is above average, so it's going to pull the average up. It continues to pull the average up even when marginal starts to diminish. You know, diminishing marginal productivity sets in here after the 4th worker. So when we add the 5th worker, marginal product begins to diminish. But what you will notice is it's still above the average. And so it's going to pull the average up. Once diminishing marginal productivity sets in, marginal product is heading south and it's not turning around. So at some point after marginal starts to diminish, it's going to intersect and be equal with average. It's going to keep going down the more input you hire, and therefore you will notice that average turns around and starts to decrease when marginal is beneath it. Average is pulled up if marginal is above it. Average is pulled down if marginal is beneath it. That's always the case, and this is a very important relationship because, again, what we're going to do in the future is take these production curves and assume that we actually have to pay for these inputs. And we will turn these production curves into cost curves by merely assigning a dollar cost to these inputs. So these relationships are very important, and they're the same no matter what the variable is. We're talking about production, we're going to talk about costs, we're going to talk about revenues, we're going to talk about profits. The relationships are always the same. And what I want to do now is show some charts between total, marginal, and average so we can see the relationships.